Hello, this is Dr. Harper. This video is an Operations Management BANA 3000 section E02 online section, spring 2021. And this is the homework number 6. I'm just going to do Johnson's rule. The others should be straightforward from the video and from the lectures, but I'm just going to cover the last question, which is the Johnson rule question in the homework, just to show how to do it. Now, if we bring up Canvas, under Canvas, under the in my website, mdharper.com, under Operations Management tab, we come down into Scheduling. Under Johnson's rule right here, this video number 1, if we open this up, this at the end of it, this does
Welcome to the Harper Classroom.
This does cover exactly how to do it here at the end. So I've already covered that, and so some people I think have already started this, have already done this, and learned it from this, which is perfectly fine. So I go through a lot more here than I'm going to do in this video. But you've already done it, and that's perfectly fine, and that's good. But on this video, I'm just going to bring up the homework. I'm just going to go over, here's homework number 6, go down and just go over the last question here. And all of these pretty much, I hope, I'm trusting, are straightforward from the lecture. Now this down here, I'm going to take this and I'm going to actually go in and solve it and show you how to solve it. Okay, not all the way through, but I'll show you right down to almost to the solution. Okay, so let's take this Control C, copy it. Let's bring up Excel. Here we go. And let's just put it right here. Control V. And let's enlarge this so we can see what's going on. Okay, good. Okay, now the first thing I'm going to do, as we did in the video, I'll do just like I did in the video that I just showed you in the website, but I will do it briefly in a shortened version to just answer the question in the homework. Because the question in the homework simply says, consider the minimum processing time that can be achieved for the entire project. What is the minimum processing time? That's all there is to it. Okay, so we're not in the video. I cover a lot more information, but all we need is just one of those diagnostics, and that is the total processing time. So let's do that. Here's how you do it. First, we do Johnson's rule. So this is early versus late, and it's an if statement. If this first one, the first server here, at that time, is less than the second time, then, comma, colon, E colon, that's going to be designated as an early in an early proposal. Okay, comma. If it's not, it will be designated as a late proposal. Comma, common, L, comma, quote, L, quote. That's the late. Okay, that's going to be in the late. That's going to be back. And that's the Johnson's rule concept, where the shorter times on the first server are early in the schedule. The shorter times on the second server are later in the schedule. Okay, return. And then I copy this down all the way down. Copy it down all the way to the end. There we go. And there's my early lates. And notice how they're spread through. Let's center everything. Everything is spread out. So then I just want to sort it. So let me highlight everything here. Up. Let me just do it to here. So let's sort this thing. Okay, let's go to Data. Under the Data tab over here, under Sort. And I'm not going to do this way. Let me go up. Here we go. Now when I go Data and then Sort, it's going to say, okay, does my data have headers? No. In other words, the first row of what I highlighted is not my header row. It's actual data. So I unclick that. It's not header. So now sort by what column? Well, I want to sort column F here. Column F, the cell values, and we can see it's alphanumeric, A to Z. Yeah, E comes before L. So yeah, so the E will be sorted first. The L will be sorted second. So that's my first sort. But then I want to add a level. I also want to sort the D column here. Let me say the D column. And I want to sort that from the smallest number to the largest number because I want the smallest numbers first. And that's smallest to largest. It's already there, so I say OK. And there I did. I sorted everything. OK, now notice the down here I have the shortest to the longest here, but I want the shortest down here. So this last half here, I go back to my data and my sort, but now let me delete one of these levels. Now I want to sort column E here, column E, but now column E, from what I've shaded, I want this not to be the smallest to the largest. I want this to be the largest to the smallest because I want the smallest down here. So right here I say largest to smallest. And there it is. I say OK, and there I did it. So now my smallest is down here, and I work my way to the middle. My smallest is here. I work my way to the middle. Boom, that's the Johnson's rule schedule. So that right there is the proposals in a sequence for the Johnson rule schedule. So now we know how to schedule that in this company. But then how long is it going to take? Well, there's where we do the calculations. Let me enlarge this so you can see it. There we go. Okay, first I want the flow on the first server. Okay, and essentially what that's going to be is going to be equals the duration, the time, and it's going to be equal this duration plus the duration above it. Whoop. And there it is. Okay, and then I copy this down all the way to the end. So that's the flow for the on the first server. Okay. Now I want the flow on the second server. On the second server, that's a little different. Okay. On this one, we want the processing time here. We want to equal the processing time plus when does it start? Well, it starts when the first one finishes after 14 minutes. Okay. Now we can start it. Now the second one's a little bit different. Okay. Now the second one, enlarge this a little bit. The second one says, okay, it's going to be that processing time plus when does it start? Well, when it starts really depends on when this job is finished on the first server, day 30, or when, let me back up here, or when this starts here, or when the second server is finished on the previous job. It's going to be the maximum of those two numbers. Okay, so I'm going to say equal this 22 plus the maximum of these two numbers, which is 30, comma, and this other number over here, which is that number there. Okay, in other words, right here, notice what I have. It's going to be 22 here. Let's highlight this. 22. Do it this way. 22 plus the max of 30 and 33, because that's the first. That's when it can start. And then I copy that down. Now, if I copy this all the way, this will be the answer. Let me come down to here. And let me stop right here. This right here, box that in. Actually, let me shade it. Okay. If I copy this down all the way, that's going to be the answer down there. That's your answer. Okay. So I don't want to do it because I don't want to really steal your thunder. I'll let you do it. Just follow what I did here and then go all the way down. Actually, follow what I did to make sure you get these numbers in here. Let me center everything so it's easy to see. Okay, 14, 30, 49, 72, 98, 33, 55, 80, 108, 139. If you get that, copy that all the way down and you'll have the answer right there. And that's how you work this problem number 6. and then it'll be one of these numbers here. Okay, now that that should tell you work number 6. Now, as I say, hopefully the other questions on this homework should be straightforward. Some people have already turned things in, so it's due on Sunday. And that's all I have for this. I hope this helps. Between now and the next time I see you, I want to urge everyone, take care.